Hello, this is today's Algebra 2 lesson for Tuesday, November 19th. I am starting on page 33, and your homework tonight after this brief lesson will be on page 34. Today's lesson is solving exponential equations. We will do it graphically, we will do it symbolically, which is algebraically, we will do it numerically and verbally. And the first problem that we're looking at on page 33 is 10x equals 50, and they're asking us to solve using these four methods I just described. Now, the one or one of them that will be familiar to you is what we say verbally when we've used our what power language. So, anytime I'm showing you notes, you can hit pause of this video at that time to copy them down as I talk. What power of 10 equals 50? So the language I used in class was more like, what power do I raise 10 to get 50 as an answer? And that question is asking, what should the exponent be that 10 is raised to so that my answer equals 50? Well, if we look at numerically, we can see that there is no power that we know of, either by doing it in our heads or in our calculators, that we can raise 10 to get 50 as an answer. If we do 10 to the first, we get 10. If we do 10 squared, we get 100. 50 is between those numbers, so if we were talking numerically, we would say the exponent would be a number between 1 and 2. Of course, there are more accurate ways of getting the answer to 10 raised to the x equals 50, and that includes graphically. So the first thing you would do is take out your calculator, and you would put the exponential. The exponential is 10 raised to the x. That's going to go in y1 in your calculator after hitting the y equals button. The 50 is going to go into y2. So then that's going to create a horizontal line, and the curve of the exponential is going to intersect with the horizontal line of 50. And that's going to look something like this. This actually might be the graph of the problem below, but it'll still look something like this. Let me call up the calculator so that you can see it. So here is y1 equals 10 to the x, y2 equals 50. When I hit graph, if I do not see the horizontal line where y equals 50, I'm going to either do zoom fit, or I'm going to change my window to a y max of, let's say, a little bit more than 50, let's say 65. And now when I hit the graph button, you can see both the exponential curve and you can see the horizontal line, y equals 50. Now our way of finding an intersection on this calculator is hitting the second button and then trace, and then you can see intersection is number 5. Now, this does not require you to do anything except hit the enter button 3 times in order to find what the x value is where 10x equals 10 to the x equals 50. So I'm just going to hit that enter button 3 times, and if I look down here under the word intersection on my calculator, I can see that if 10 is raised to the 1.69897 power, that will equal a y value of 50. So that's one way that we can solve this problem. And here graphically, so that you can write it down and hit the pause button, I've drawn the picture and talked about the solution. Now, what we're mostly going to be focusing on in this part of the lesson is solving these algebraically. Now, solving algebraically goes back to our exponential and its inverse, which is log. So if I have the problem 10 raised to the x equals 50, I can use what I know about inverses to undo the exponential. I'm going to undo the exponential by taking the log of both sides. Now, this is one way to write it. I can write it another way, and that is I can do log. Let me do it with my finger. Of 10 to the x equals log of 50. Now, when I do that, I am basically undoing the exponential. So remember that log on our calculator is log based 10. So if a log undoes an exponential, the only thing I have left is my x value. So x equals log of 50. And now I can call up my calculator again, and it can give me the same answer as my intersection. Remember, the answer to my intersection was, let me call up the calculator again. 1.69897. And now if I quit the graph and I just hit the log button, which is already log base 10, and I do log base 10 of 50, I'm getting the exact same answer as my exponential, 1.69897. So this is the way that we are algebraically going to be solving for our exponential problems using logs, which are the inverse of exponentials. Next problem on the same page, we'll do it the same way. If we talk about it verbally, we're going to say, what power do I have to raise 2 to get 28 as an answer? What power do I have to raise 2 to in order to get 28 as an answer? Well, obviously I wrote power twice. You can ignore this. And then hit pause so that you can write down this verbal way of solving the problem. And then we can go up to numerically, and we can look at different powers of 2 that may give us an answer of 28. 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 raised to the 4th power is 16, and 2 raised to the 5th is 32. So none of those answers equal 28. So in that case, just like the one above, we can say that our exponential answer is an exponent between 4 and 5. So our next way of solving is graphically. This time we're going to put 2 to the x power in y1. We're going to put 28 in y2. And then we're going to use our intersection button to solve the problem. So it's going to be now 2 raised to the x. Can you turn that off, please? Thank you. And then I've got 28 in y2. Here is my graph. Luckily, we can see the intersection right away without adjusting the window or hitting zoom standard. And once again, to find the intersection, which is the exponent answer, it's second, calc, 5. Look for your cursor, it's down here. Maybe you want to move it just a little closer to the red and blue intersection, or on your calculator, the intersection of the curve and the horizontal line. And you are just going to hit the enter button 3 times. So this answer is 4.807 if I use my calculator. Now we're going to use logs again to solve our problem because logs undo exponentials. So I'm going to have 2 to the x. I'm going to log both sides. Now, I know that log 10 is not the same or exactly the inverse of 2 to the x. That would normally be log base 2 of 2 to the x. But since most of us have calculators that just have the log button, I'm still going to log base 10 both sides. But I want to show you something really cool about logs when you log both sides. Just like in the previous problem where the exponential goes away, if I do log 10 of both sides, this x is going to move to the front of my math problem. So now the problem looks like this. X times log base 2 equals log of 28. And then remember, our goal in algebra is always to get the x by itself. So your last step is going to be divide both sides by log 2. So on your paper, you're going to write log 2, x log 2 divided by log 2. On the right, you're going to write log of 28 divided by log 2. And then when you put in your calculator this specifically, hitting the log button and 28, and then doing division, and then hitting the log button and then 2, you're going to get the same answer as your solving graphically by finding the intersection. These are the same answers. So on the next page, 34 is your homework. There are 2 problems that are just like the problems on page 34. You're going to solve them verbally using the what power language, numerically finding the exponent that the answer is between. You're going to use your calculator to do it graphically by finding the intersection, and then you're going to do it symbolically by using the log button on your calculator. Please hit rewind and pause if you need to get these notes to do page 34 in your packet. I will see you on Wednesday.